Have you ever wondered what makes paracetamol so effective? Let's dive into the world of this common yet fascinating molecule. Synonymous with pain relief, paracetamol, also known as acetaminophen, is a household name around the globe. As an over-the-counter medication, it's the go-to remedy for a wide array of ailments. From the throbbing pain of a headache to the discomfort of a fever, paracetamol is always at the ready. It's an analgesic, meaning it alleviates pain. It's also an antipyretic, which in simpler terms means it's a fever reducer. So whether you're battling a fever or trying to keep pain at bay, paracetamol is often your first line of defense. But it isn't just about pain and fever. Paracetamol also plays a role in managing inflammation. Although it's not as effective as some other drugs at reducing inflammation, it can still lend you some relief. Now, you might be wondering what makes paracetamol so widely accepted. Its safety profile and effectiveness are key. When taken as directed, paracetamol poses minimal risk of side effects. That's quite a feat for a medication that's so universally used. Of course, like any drug, it's not completely risk-free. It's important to stick to the recommended dose to avoid potential harm, such as liver damage. But generally, its benefits far outweigh its risks, making it a staple in medicine cabinets around the world. And here's another interesting tidbit about paracetamol. It's been around for over a century. Discovered in the late 19th century, it has withstood the test of time, continuing to provide relief for countless individuals each day. So, the next time you pop a paracetamol, remember the immense relief it brings to your system. It's not just a pill, it's a molecule that's been meticulously designed to ease your discomfort. Now, what exactly is paracetamol made of? Let's dive into the chemical structure of this common yet fascinating compound. Paracetamol is an organic molecule with the chemical formula C8H9NO2. This means it's composed of 8 carbon atoms, 9 hydrogen atoms, 1 nitrogen atom, and 2 oxygen atoms. Delving deeper, the structure of paracetamol reveals a benzene ring at its core. This hexagonal ring of carbon atoms is a staple in organic chemistry, providing a stable and versatile foundation. Attached to this ring, you'll find an amide group, a combination of nitrogen, carbon, and oxygen atoms, and a hydroxyl group, a pairing of oxygen and hydrogen. These particular groupings are not just for show. The amide group contributes to paracetamol's solubility, making it easy for our bodies to absorb. The hydroxyl group, on the other hand, plays a crucial role in the drug's pain-relieving and fever-reducing effects. The complex structure of paracetamol is what makes it a powerful tool against pain and fever. What are the physical and chemical characteristics that define paracetamol? Let's start with its physical features. Paracetamol, also known as acetaminophen, is a white, crystalline powder. It's quite unassuming to the naked eye, but don't let that fool you. This humble compound has a melting point of around 169 to 171 degrees Celsius. Now that's hotter than a summer's day in Death Valley. Paracetamol isn't very soluble in water, but it's readily soluble in organic solvents like alcohol. This is why you'll often find it in liquid formulations like cough syrups or infant drops, dissolved in a mixture of water and alcohol. Now let's delve into the chemical side of things. Paracetamol is a phenacetin derivative, with the chemical formula C8H9NO2. It's a fascinating compound that works wonders in our bodies by acting on the central nervous system. It does this by inhibiting the production of prostaglandins, substances that our body produces in response to injury or illness. These prostaglandins cause inflammation and amplify the signal to our brain that we perceive as pain. Paracetamol steps in and says, "Not so fast." It puts a halt to the production of these pesky prostaglandins, reducing inflammation and pain. It's like a superhero swooping in to save the day, bringing relief to millions around the world every day. But it's not just a pain reliever. Paracetamol also has antipyretic properties, meaning it can reduce fever. It does this by acting on the hypothalamus, the part of our brain that controls body temperature. By resetting our body's thermostat, it helps us cool down when we're running a fever. That's the beauty of paracetamol. It looks simple, but its action is complex and multifaceted. It's a testament to the power of chemistry and how a small white pill can make a world of difference in our lives. Even though it's just a small white pill, the properties of paracetamol are fascinating and complex. So, what have we learned about paracetamol today? Quite a lot, it appears. Let's take a moment to wrap up our discussion. Paracetamol, also known as acetaminophen in some countries, is a common over-the-counter medication used primarily for its analgesic and antipyretic properties. It helps to alleviate pain and reduce fever, making it a staple in many households and medicine cabinets. The effectiveness of paracetamol can be attributed to its unique molecular structure. It's an organic molecule composed of a benzene ring core, attached to an amide group and a hydroxyl group. This structure allows it to interact with our body's enzymes and produce the desired effects. The physical and chemical characteristics of paracetamol further enhance its function. It's a white, crystalline powder that is soluble in water, allowing it to be easily ingested and absorbed by the body. Chemically, it's stable under normal conditions, and it doesn't react with most other substances, which means it's safe to take with most other medications. Furthermore, paracetamol's structure and properties make it an effective painkiller and fever reducer. It works by inhibiting the production of prostaglandins, chemicals in the body that signal pain and inflammation to the brain. By reducing these signals, paracetamol helps to ease pain and lower fever. But remember, while paracetamol is generally safe when used as directed, it can cause liver damage if taken in large doses. So always follow the recommended dosage and consult your healthcare provider if you have any concerns. In conclusion, paracetamol is a fascinating molecule that plays a crucial role in modern medicine. It's a prime example of how understanding the science behind everyday items can give us a deeper appreciation of their value and importance. Next time you reach for that small white pill, you'll have a deeper understanding of the fascinating science behind paracetamol.